This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A plumbing rough-in can be perfectly functional and still leave the building damaged. A pipe may hold pressure, drain correctly, and pass through the exact space the plumber needs, yet the root may put that pipe in the path of a future screw, cut too much wood from a bearing stud, break the continuity of a top plate, or place an excavation inside the support zone of a footing. The general B responsibility is not specialty plumbing design. The responsibility is coordination, protect the piping, protect the structure, and stop the work when either one is being sacrificed. I want you to hold on to one central idea for this entire lesson. Every penetration trades away something. A hole, notch, sleeve, or trench creates room for the plumbing, but it also removes material or enters space that another system depends on. Good field supervision means recognizing where that trade is permitted, where added protection is required, and where the specialty contractor needs an engineer, an approved repair, or a different route. The simplest example is a pipe close to the face of framing. California requires protection when plastic, copper, or copper alloy piping passes through a framing member and comes within 1 inch of the exposed framing face. That 1 inch is the trigger. Once the pipe is inside that zone, the pipe needs a steel nail plate. The plate is not just any scrap of sheet metal. It must be at least number 18 gauge steel, with a minimum thickness of 0.0478 inches. It must also extend along the framing member at least 1 1/2 inches beyond the outside diameter of the pipe or tubing. I put the nail plate requirements together on this chart because the 3 parts belong in one memory. 1 inch triggers protection, number 18 gauge establishes the plate, and 1 1/2 inches establishes the required extension beyond the pipe. The practical cause and effect is easy to understand. After rough plumbing is concealed, the finished trade cannot see the line. A screw or nail can enter the framing along a blind path. If the pipe sits too close to the face and no proper plate is installed, the fastener can puncture the concealed piping. The steel plate acts as a deflection shield. It tells the fastener that this is not an open fastening zone. That is also why a plate that barely covers the visible circle of the pipe is not enough. A fastener does not always enter perfectly straight. The required extension gives protection beyond the pipe diameter, where an off-angle fastener might otherwise slip past a small plate. During a pre-drywall walk, I would not merely look for some metal over the hole. I would verify the pipe is actually within the trigger zone, confirm the plate is steel of the required gauge, and check that the coverage extends far enough along the framing. A plate can look present and still be undersized. When piping passes through concrete or masonry walls, the coordination problem changes. The concern is no longer only a hidden fastener. The building material itself is dense, rigid, and capable of transferring load or movement directly into the piping. California requires piping through concrete or masonry walls to be protected by sleeves. The piping also must not be subjected to load from the building construction. I treat those as 2 connected checks. First, is there a proper sleeve around the penetration? Second, is the pipe isolated so the wall is not bearing on it? A sleeve is not permission to improvise the opening after the structure is complete. Penetrations through structural concrete or masonry must be coordinated with the plans, the affected specialty contractor, and the responsible design professional when the opening affects structural work. The general B boundary matters here. I supervise the interface and protect the structure, but I do not invent a structural repair or redesign a plumbing system in the field. Imagine a crew that finds a missed wall penetration after the concrete has cured. The tempting shortcut is to start cutting until the pipe fits. That decision can create a structural issue that is far larger than the plumbing problem. The correct supervisory move is to stop, identify what the plans permit, and obtain the required direction before altering structural work. Wood framing creates the most common coordination conflict because a plumbing route may need to cross a series of studs. The key distinction is whether the crew is notching the edge or boring through the member. A notch removes material from the edge. A bored hole removes material closer to the center. Those are not treated the same. In an exterior wall or bearing partition, a stud notch may not exceed 25% of the stud width. In a non-bearing partition, the notch may not exceed 40% of a single stud width. For bored holes, any stud may be drilled when the hole diameter does not exceed 40% of the stud depth. The limit can increase to 60% when the stud is doubled, with no more than 2 successive doubled studs bored. The edge of the bored hole must remain at least 5/8 of an inch from the edge of the stud. The chart separates the numbers by the action being taken. For a bearing or exterior stud, think 25% for a notch. For a standard bored hole, think 40%. For the specific doubled stud condition, think 60%. Then keep the 5/8 inch edge distance separate from all 3 percentages. The underlying physical distinction is useful because it makes the numbers easier to remember. Cutting a notch severs the outer wood fibers, so the allowance is tighter in a bearing or exterior wall. Boring near the center preserves more of the outer edge, but the hole still has size and edge distance limits. I'm not using that explanation to turn you into the engineer. I am using it to help you avoid mixing up notch numbers with bore numbers. Suppose a plumber needs a horizontal drain through a load-bearing wall framed with 2x4 studs. A standard 2x4 is 3½ inches deep. If the crew cuts a 1½ inch notch across the face, the notch removes roughly 42% of the stud width. That is far beyond the 25% limit for a bearing wall. The field decision is not to cover it and hope the inspector accepts it. I would stop concealment, identify every affected stud, document the condition, and require an approved repair or replacement under the direction of the responsible structural professional. The plumbing route may also need to change. Once the framing has been overcut, a nail plate does not restore the missing structural capacity. Nail plates protect pipes from fasteners. They are not structural repair straps for damaged studs. This is a recurring general B distinction. Protection hardware is not interchangeable. A nail plate, a sleeve, a top plate tie, and an engineered stud repair solve different problems. Their presence means nothing unless each one is being used for the condition it was designed to address. Top plates deserve their own check because a large vent or drain can remove a substantial portion of the plate. When a top plate is cut, drilled, or notched through more than 50% of its width, California requires a galvanized metal tie across the opening. The tie must be at least number 16 gauge and at least 1½ inches wide. It must extend at least 6 inches past the opening on each side and be fastened with at least 8-10 penny nails, each at least 1½ inches long on each side. The tie is fastened across the cut with the required nailing on both sides of the opening. The practical effect is continuity. A top plate connects the wall framing along its length. When more than half its width is removed, the metal tie bridges the interruption, so the wall is not left with an unaddressed break at the plumbing opening. I want to emphasize the threshold language. The requirement is triggered when the top plate is cut through more than 50% of its width. That is different from the stud notch and bore limits. It is also different hardware. The top plate tie is number 16 gauge. The pipe nail plate is number 18 gauge. Mixing those two gauges is an easy mistake when the numbers are studied without the condition attached. My memory connection is simple. The thinner protection question is at the pipe face, where number 18 gauge deflects fasteners. The heavier continuity question is at the top plate, where number 16 gauge ties across a major cut. I remember the condition first, then the gauge. The same coordination principle moves underground. A trench is another penetration, except now the material being removed is soil that may be supporting a building. California applies a 45-degree clearance rule when a trench is deeper than the footing of a building or structure and runs parallel to that footing. The trench must remain outside a 45-degree plane extending downward and outward from the bottom exterior edge of the footing. The trench coordination chart keeps 3 separate questions together. Is the trench entering the footing support zone? Does the water service have the required cover? If water and certain sewer materials share a trench, Is the water line elevated and separated on a solid shelf? For the footing question, picture an invisible diagonal line dropping outward from the bottom, outside corner of the footing. If a parallel trench is deeper than the footing, the excavation cannot cross into that protected zone. The soil beneath and beside the footing is carrying and distributing building load. Removing soil from that zone can take away support and create settlement or trench wall instability. The scope limitation matters. This 45-degree rule is for a trench running parallel to the footing. I would not automatically apply the same simplified rule to perpendicular crossing or to a condition requiring underpinning. Those situations may require different details and professional direction. Consider a hypothetical project with an existing footing that ends 2 feet below grade. A proposed sewer trench will run parallel to the wall and reach 5 feet below grade. If the trench is placed only 1 foot from the footing, the excavation enters the protected zone described by the 45-degree rule. I would stop that layout before digging, coordinate a reroute, or obtain the required structural and geotechnical direction. The correct time to solve that conflict is during layout, not after the excavator has removed the supporting soil. Water service yard piping has a statewide minimum cover of 12 inches below finished grade. Finished grade is the reference point, not the rough trench surface before final grading. A local jurisdiction may require greater depth for conditions such as frost, but the statewide baseline in the source material is 12 inches. Water and sewer piping also create a common trench confusion. The safe study rule is not that the two systems can never share a trench. California provides a specific arrangement when water piping shares a trench with building sewer piping made of clay or other materials not approved for use within a building. The water pipe must sit on a solid, undisturbed shelf cut into the side of the trench. It must be at least 12 inches horizontally to the side of the sewer. The bottom of the water pipe must also be at least 12 inches above the top of the sewer at every point. I picture a stair step in the soil. The sewer stays in the lower trench. The water line sits on the higher side shelf, 12 inches over and 12 inches up. That picture keeps the two measurements connected without turning them into one vague idea of separation. The supervisory check begins before installation. I would confirm whether the proposed lines are even subject to the shared trench condition. Then verify the shelf is solid and undisturbed. The horizontal distance is present and the vertical relationship is maintained along the run. A shelf that collapses, narrows, or changes elevation can defeat the required arrangement even if one spot looks correct. Trench safety uses a different set of numbers, and these are worth memorizing as a sequence. 4 feet triggers safe egress. 5 feet triggers cave-in protection and the California excavation permit condition described in this research. 25 feet is the maximum lateral travel to reach the egress. 2 feet is the minimum setback for spoil piles and equipment from the trench edge. I put those 4 numbers in one sequence table. 4, 5, 25, 2, 4 for getting out, 5 for protection and the permit threshold, 25 for travel, 2 for keeping the dirt and equipment back. At 4 feet or more in depth, a trench must have a stairway, ladder, ramp, or other safe means of egress. The location must keep every worker from traveling more than 25 feet laterally to reach it. 4 feet does not mean the worker can simply climb the trench wall, and it does not mean one ladder at a distant end is automatically enough. At 5 feet or more, a trench into which a person must descend requires a protective system against cave-ins, such as sloping, benching, shoring, or shielding, unless the excavation is entirely in stable rock. The California permit requirement also applies before digging a trench 5 feet or deeper when a person will descend into it. Do not merge the triggers. 4 feet is the egress threshold. 5 feet is the protection and permit threshold. A trench that is 4 1/2 feet deep may not yet be at the 5-foot protection threshold described here, but it still needs safe egress within the 25-foot travel limit. Suppose workers are repairing a line in a trench that is 4 1/2 feet deep. Their only sloped exit is 30 feet from the work area. The problem is not that the trench has crossed 5 feet. The problem is that it crossed 4 feet and the workers must travel more than 25 feet to get out. I would correct the egress immediately before allowing work to continue. Spoil piles and equipment create another separate number. Excavated material and equipment must be kept at least 2 feet from the edge. The soil removed from the trench can roll back in, and its weight adds load near the trench wall. The 2-foot setback is not the same as the 25-foot ladder travel distance. I also want to keep the general B-roll clear. I'm not teaching you to design shoring or calculate soil loads. The supervisory decision is to recognize the trigger, require a compliant protective system, verify the permit condition, and stop entry when the trench is not ready for workers. A strong coordination walk follows the order in which problems become expensive to fix. Before wall covering, I check every plumbing penetration through studs and plates. I look for pipes within 1 inch of the exposed framing face, verify proper nail plates, distinguish notches from bored holes, and identify framing cuts that exceed the permitted limits. I check large top plate openings for the required tie. I do not assume that the plumbing inspection alone resolves a structural framing defect. Before concrete or masonry closes around a penetration, I confirm the sleeve and verify the pipe will not carry building load. If the opening was not planned, I stop the field alteration and get the proper direction instead of allowing a crew to create its own structural solution. Before trenching begins, I compare the utility route with the building footings, final grades, and other underground systems. I identify parallel runs that could enter the 45-degree footing zone. I confirm the water service cover and any required water and sewer separation. I also confirm the safety setup before a person enters: access, protective system, permit condition, and spoil setback. During the work, I document changes and keep the affected trades aligned. A route adjustment by the plumber can create a framing issue. A framing repair can change the available pipe path. A trench reroute can affect grade, utility separation, and inspection sequencing. The point is not to supervise each trade in isolation. The point is to protect the interfaces where one trade can quietly damage another system. Here's the central principle again. Every penetration trades away something. The pipe needs space, but the building still needs its load path. The trench needs depth, but the footing still needs supporting soil. The worker needs access, but the excavation still needs protection. I decide whether the trade is permitted by checking the correct threshold for the correct condition. For the framing side, remember 1 inch, number 18 gauge, and 1 1/2 inches for pipe protection. Remember 25% for a bearing or exterior stud notch, 40% for a standard bore, 60% for the permitted doubled stud condition, and 5/8 of an inch at the stud edge. Remember more than 50% through the top plate triggers the number 16 gauge tie, 6 inches past the opening, and 8/10 penny nails on each side. For underground coordination, remember the 45-degree plane for a trench deeper than and parallel to a footing. Remember 12 inches of water service cover. For the specific shared trench condition, remember the water line on a solid shelf, 12 inches to the side and 12 inches above the sewer. For trench safety, use the sequence 4, 5, 25, 2. 4 feet for egress, 5 feet for cave-in protection and the permit condition, 25 feet maximum travel to the exit, 2 feet back for spoil and equipment. There is an audio practice quiz for this specific episode, and I made it to reinforce these exact piping, framing, and trench coordination decisions. It is audio-based, the questions are read aloud, and you answer by tapping, which makes it practical when you are studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. I read those questions, and they help me see where a rule needs a clearer explanation. Subscribe so you can stay on track through every episode until you get your license. I am here to help you keep moving, one focused lesson at a time.